Okay, we have here today another integral. This one's from the MIT Integration Bee 2024, regular season number 8. You have the integral of arctan square root of x dx. Okay, now typically whenever I have arctan integral, the first thing I'm thinking about is integration by parts. But I think before I get to integration by parts, I want to kind of clean it up a little bit. I want to do a u substitution just for that square root of x. So coming over here, we'll have u equal to square root of x. Before I take the derivative, I'll just solve for x by squaring both sides, and we get x equal to u squared. Take a derivative, and then we have dx equal to 2u du. And then I'll just go ahead over here and substitute. So we're going to have, this is going to become arctan of u here, and then our dx will be this. We'll just have 2u du. And now we've created two things. This is going to be the perfect case for integration by parts. So I'll come over here. I'm going to use the DI method on this, or tabular integration. We'll differentiate arctan of u because that's going to help us. And we'll differentiate this other part, 2u. Now differentiating arctan of u, this is just going to give me 1 over u squared plus 1. And then integrating this, I'll leave the 2 in front for now. We'll have u squared over 2. But now I could cancel the 2's right here. But what I want to notice, now this last row is going to be an integral. And what I want to do is use a trick that I often forget about, but someone then reminds me in the comments to use it, and then I forget again, and then someone reminds me again. But what I want to do is use this trick where we can actually, because this is an integral here, we integrated from 2u to this, well, I can actually include this plus c if I want. We don't need to include it because in the integration by parts it vanishes, so it doesn't affect the problem, but we can actually use this and kind of create it to be whatever we want. And so what I want to do for this plus c is I want to write it as a 1, but actually the way I want to write this, I don't want to have it as a 1, let's write it as 2 over 2. The reason I'm doing that, if we come over here and do some stuff with this, we clearly have a common denominator. I can write this as 2u squared plus 2 over 2. Factoring a 2 out, we get u squared plus 1 over 2. But that's going to leave me with just u squared plus 1 when we cancel out the 2's. And the reason for doing all that is just to get the u squared plus 1 to cancel out with what we have here. So now that we have our table all filled out, now we can finish it off. So first we're going to have part of our solution here on the diag, and we'll have u squared plus 1. Arctan of u, and then this integral, when we put this together, we're integrating minus u squared plus 1 cancels with u squared plus 1, we're just integrating 1 du. But integrating 1, we're just going to get a minus u here, and all I need to do is just back substitute in order to finish this off. So back substituting now, our u squared is just going to be x, this is going to become x plus 1 arctan square root of x minus square root of x plus c, and that's it. Okay, there you have it. Pretty straightforward problem with integration by parts. Thanks everyone for watching. Have a good day.